last Algebra 2 lesson, but here's some help on exponential equations. Work next week. We'll have a little bit in con, but it won't be directly related to this. Hopefully a little bit more fun stuff. But it's solve an equation. Remember, equality, still got to do on one side what you do on the other. First thing, I want to get this e by itself. So 6 times to do the inverse of multiplication, I'm going to divide. So I basically have e to the 0.25t equals 9 over 6. And some of y'all realize, hey, that is 3 over 2. All right. Now, how do you undo exponentials? Well, hopefully you're seeing that the logarithms are inverses. The e value, if I take the natural log of both sides, that will allow me to move the exponent down. So by taking the natural log on both sides, I just have that 0.25t, or t over 4. If you leave it as 0.25t, that's fine also, because these basically undo each other, is equal to the natural log of 3 over 2. And how do you undo division? Well, you'll multiply this entire thing by 4. So I get that t is equal to 4 natural log of 3 over 2. And notice there's a lot of ways you can write that. You can write it still with the 1/4, 0.25, like this, with the decimal. It will accept all of those. But that's what you're basically going to do on every one of these. You're going to get the 10 to a power by itself, or the e by itself, and then take the natural log or the base 10 log on both sides to move exponents down, and then repeat your operations. So going through a few more. Another one. So first thing that I'm going to do is I want to move the 9 to the other side. So if I divide both sides by 9, hopefully you see that e to the 2z is equal to 6. Again, the 6 just came from 54 divided by 9. Now, how do I undo, or what's the inverse so that I can move this down? Well, I'm going to take the natural log on both sides. I'm taking natural log because it's e. So the inverse. So I have 2z equals the natural log of 6. And to solve that, I'm going to divide both sides by 2. So there's my answer. Notice it will take that as such. It will take it as 0.5. I don't think it'll count off there either. But a lot of ways to put that in. But there's your answer. Now here we've got base 10. So we're going to use plain log. We're not going to use the natural log here. But first step is I'm going to divide by 11 on both sides. So I have 10 to the 5t is equal to 20 over 11. Now to move this down, I'm going to take plain log. You don't even have to put in the little base 10. It's understood, you know, that's what it's going to be. And you would get 5t equals the log of 20 over 11. And then final answer, I'm going to divide that by 5, or you can put it as 1/5 log 20 over 11. It will take it, I believe, just over 5. Some of you wrote out an expanded form. A lot of ways that it'll accept that answer. So whatever's easier for you to type in. But again, get rid of the multiplication, take your natural log or your logarithm, usually multiply or divide to finish that up. This one, if I take my negative 28 and I divide that by more, first divide by negative 3 on both sides. So we have 10 to the 2t equals, I'm just going to make that a positive, 28 over 3. Plain logarithm this time. So I'm going to have 2t equals the log of 28 over 3. Last step, I'm going to divide that by 2. And you can leave your answer like this. You can put it as 1/2 log 28 over 3. And final problem for now, first step, I have e to the 2.7x equals 33 over 4. Okay.
Wilson, I'm just gonna get a snack.
Taking natural log on both sides gives me 2.7x equals, and final step, I'm going to divide that by 2. So I believe it will take it just like that. But again, all these are going to work the exact same way. I know it sometimes gets a little tedious entering them in if you don't put your fractions correctly. But I worked through those last logarithm exercise that we're going to do this year, finish up. And I hope y'all are doing well and have a great weekend. Bye-bye.